All right, now as we continue to look at trigonometry, we're going to take a look at the trigonometric ratios. So now you're going to finally get a chance to see what those sin, cos, and tan buttons do in your calculator and how they actually are pronounced and spelt, because they're all three abbreviations. So a couple things that you do not want to forget, and this is going to be very important, otherwise could cause a lot of trouble with it. Trigonometric ratios aren't that complex. The hard part is just ensuring that you're consistently labeling your triangles correctly and that you are making sure that you're doing your calculations in degrees and not in radians or gradians, which are another unit your calculator could be set into. We'll talk about that when we get to it. But first things first, do not forget that opposite means across from and adjacent means beside. Okay, if you can memorize those two concepts, then you shouldn't have any trouble labeling your triangles. So moving from that, a little relation to our similar triangles. Here's a diagram with a series of similar triangles. Each time we are just increasing the height by 1, and then the base adds an extra 2. So we have 1 by 2 here. So the 1 by 2, 2 by 2, 2 by 4, 3 by 6, 4 by 8, 5 by 10, 6 by 12, 7 by 14, 8 by 16. Okay, the different triangles there. If we compare the ratio of the height to the width in each case, then we get that 1/2, 1 over 2, 2 over 4, 3 over 6, and so on. They're each 1/2. And this ratio is constant in all those triangles. And any triangle that we make that uses this angle, any right triangle, I should say, this is only going to work for right triangles. So for all right triangles, with this angle, the height and width of those sides will be the same. Notice not the hypotenuse, but the height and width sides there. And right now we're marking the angle. We don't know what it is, but we're marking it with the symbol theta. It's like a circle with a line through it. It's just a Greek letter that we often use to denote an angle. So every triangle has that same ratio of sides, and because of that, there is we can figure out, use that knowledge, and there is a series of values that we've calculated that will determine this, but we'll look at in a minute. But what we know here is that this angle here would be about 26.6 degrees. And so every triangle with an angle of 26.6 degrees, every right angle triangle, the opposite and adjacent sides, which we're going to talk about in a second, will have that ratio of 1 to 2. So if we take a look here, first thing is labeling these triangles. So as I said, in those triangles above, it was opposite and adjacent. And again, here's my angle theta. The hypotenuse is always the largest side of the right triangle. So you notice in both of these right triangles, the hypotenuse is in the same spot. It's across from the right angle. The right angle is like a little arrow pointing at it. But notice when the angle changes, when I move my theta, opposite and adjacent change. So opposite and adjacent labels are used for, that is definitely wrong. That should be beside. Scratch that out, change that to beside. Adjacent's always beside the angle we're working with. So whatever angle we're considering in the question, in this case here, if we're considering this angle, then this is adjacent, because adjacent means beside, and opposite is across from. So that's across from the angle, and that's beside the angle. That's beside the angle, there's the across from the angle there. Okay, so adjacent and the opposite will always switch to relate themselves to the angle. Adjacent will be beside the angle, hypotenuse will be the longest side, so the angle will always be wedged in between the adjacent and hypotenuse, and then the opposite will always be the one across from the angle. So make sure you get familiar with that so that you can constantly label your triangles correctly. Now, these actual ratios that we're going to talk about are sine, S-I-N-E, cosine, C-O-S-I-N-E, I-N-E, and then tangent, T-A-N-G-E-N-T. We abbreviate them on the calculator to sine, not sin, but sine, cos for cosine, and tan for tangent. And the ratios compare sides. The sine is the opposite over the hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. There's a little aid that people use to memorize these, and they use the phrase SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you can use that to memorize these formulas and the order in which the sides go. Now, whenever you're doing any work with this, it is highly important to make sure that your calculator is in degree mode. Depending on your calculator, this will be different. Some of you may have a reset button on the back or the front that you can press, and that will ensure that you're in degree mode. But generally at the top of the calendar, calculator, it'll say D or DEG, or it might have an R or RAD for rad. It doesn't mean your calculator is a rad calculator. It means it's in radian mode. You may also have a G up there or grad. We only want to use degree measure. If we use the other ones, it's going to mess everything up, because instead of having 360 degrees to make a full circle, it's 2 pi, which is completely different. So you need to make sure your calculator is in degree mode. If you are unsure how to do it, or you're not comfortable because you don't want your calculator to be screwing you up, there is the handy dandy trig tables. This here will do all the same things that your calculator can do, rounded to 4 decimal places, which we're going to be using, and will give us all the answers that we need. It's kind of like using the pi button on your calculator, or just using 3.14 for pi. So we're going to do some calculations with all this stuff now. It's not really that much. It may seem like a lot of information, but once you get using it, it's pretty straightforward. We can use sine, cosine, and tangent to find missing angles in triangles. So here I have a right triangle, and the first thing I need to do is label it, and then I can pick my formula. So here's my hypotenuse, and then the 6 is across from the angle, so it's opposite. So O and H are the two sides. There's my angle. So O and H, that's sine, opposite over hypotenuse. So sine theta is O over H. And now I just fill in those values. Sine theta equals 6 over 9. Sine theta equals, and then I'll do 6 divided by 9 and get 0.6667. We go to 4 decimal places for accuracy. Okay, so make sure you're always going to 4 decimal places. Now this is where you have options. Method 1. Take your calculator. We're looking for the angle. So when we're looking for the angle, you press Shift or second, and then the sign button. And you should get the sign to the -1, and then we'll type in that decimal, 0.667. Hit enter. 41.8, so 42 degrees. Always round to the nearest degree unless stated otherwise. So 42 degrees is my angle. Notice, now that I've pressed my second sign, I don't write sine anymore. I found the angle, I just write theta. If you write sine theta equals 42 degrees, that is incorrect. Once you've pressed that negative, sign to the -1 part, and got that out, you get your angle. Your calculator might be slightly different. It might have you type in the decimal first and then press the second sign button. So make sure you test it out. Using your calculator, that's what you should get. If you don't have a scientific calculator, or you're not comfortable with it, it's not working out, you can always pull out your sheet. All you need to do is, we're looking for sine, about 0.6666666666, repeating is what it is. I'm going to go to the sine column, and I'm going to follow it down until I find the closest value that I can to that, which comes out to right here, 0.6691. That's closest. So my answer here is 42 degrees. Same answer as I got here. And so you just go down the sine column or cos column or tangent column and match it with the angle. You may have to jump over to, these are angles from 0 to 45 in the first column. The second column is 45 to 90. And you can check those out. Let's try a couple more. In the next one here, I got 4, 4, and there's my theta. So here's my theta. So this is the adjacent side because it's beside the angle. This one's across from the angle, so that is the opposite side. So in this case, opposite and adjacent, that's going to be tan, which is opposite over adjacent. So tan theta equals the opposite over the adjacent. I'm going to fill those values in. Tan theta equals 4 over 4, or tan theta equals 1. So now I can pull out my handy dandy calculator and again press second tan 1. Here I get 45. If I use my paper, there's my tan of 1, and the angle is 45. So theta equals 45 degrees. And again, the tan is gone now that I've calculated it. One more here, finding the missing angle. Here we have the hypotenuse of 7. We got an adjacent side next to the angle. So adjacent and hypotenuse, that is our cosine. So cosine theta equals adjacent over hypotenuse. Fill those values in. Cosine theta equals 2 over 7. I divide those. 2 divided by 7 is going to give me approximately, and again, go to 4 decimal places for accuracy, 0.2857. So now I press second cos on my calculator. Second cosine of 0.2857. That gives me 73. And again, I can check on my piece of paper here. We're looking for 0.2857. And there's 72, or 74 is 2729. So it's in between 73, 74. And it looks like it's a little bit closer to 73, although I would accept 74 as an answer as well. So 73 degrees is our result there. If you notice on that table when you're searching, sine increases from 0 up to 90. Cosine is decreasing from 0 to 90. And then tangent is increasing. Anything over 1 is over 45. Anything under 1 is less than 45. Might help you move it through it a little quicker. All right, last bit here, we're going to find some sides. So as well as finding angles, we can use a little algebra to find missing sides in triangles. So if we take a look at our triangle here, here's our angle. This is the hypotenuse. Compared to the angle, this is the opposite side. So I'm looking for the opposite side. I have the hypotenuse, and I have an angle. Opposite over hypotenuse is sine. Theta equals opposite over hypotenuse. Fill in my values. Sine 30 equals x over 10. And now all I got to do, convert my sine to a decimal. So I press, in this case, when I have it as sine 30, when I have the angle, I want to convert it to a decimal. I'm just going to press sine 30. No second function this time. Just sine 30. Just like here, I get 0.5. Or on my table, I go to 30 and go over to sine, and there's my 0.5. So I got 0.5 equals x over 10. And now I just do a little algebra here, move the 10 over by multiplying. I have 0.5 times 10 equals x, or 5 equals x. So there's the length of my missing side in that triangle. In this next one, slightly different situation, as you see in a moment. So I have my hypotenuse, I got my adjacent, so that's going to give me a cosine theta equals adjacent over hypotenuse. So we have cosine of 40 equals 6 over x. And so the slight difference here is that the x is now on the bottom of the fraction. And I'll show you a quick way of solving this. First, we're going to do my cosine of 40. I'm going to pull up my handy table here, or press, my handy table says 0.7660. So 0.7660 equals 6 over x. On my calculator, again, I would just press cos of 40 and get the same value, round it to 4 decimal places. But now what I can do here, x is on the bottom. So what I'm going to end up doing is multiplying this by x, and I'm going to get 0.7660x equals 6. And then I'm going to have to divide that. So what's going to end up happening is these two are just going to switch spots. So whenever x is on the bottom like this, you could just write x equals 6 over 0.7660. Just switch the spots. And then we divide 6 by that. And I get 7.8. So x is about 7.8. So finding sides, finding angles, both of them done with either the calculator or the sheet. Again, make sure your calculator is in degree mode if you're using it. Otherwise, you can use the sheet. You always get the right answers with that one.